Next problem. Find z inverse of z into z plus 1 by z minus 1 whole cube. Let capital F of z, which is equal to z into z plus 1 by z minus 1 whole cube, right? And multiply by z n minus 1 on both sides. You will get f of z into z power n minus 1, which is equal to z power n minus 1 z into z plus 1 by z minus 1 whole cube. Now grouping z power n minus 1 and that is z. So grouping the powers. So z power n minus 1 plus 1 because z power 1, right, into z plus 1 by z minus 1 whole cube. Minus 1 and plus 1 get cancelled in the power of z. So you will get z power n z plus 1 by z minus 1 whole cube, right? Now to find the poles. From that poles we can find residues. From that we can easily find the z inverse, right? Now for the pole of f of z into z power n minus 1 are given by, so you put the denominator equal to 0. So take the denominator, that function is equal to 0, right? Z minus 1 whole cube equal to 0. So z is equal to 1 is a pole. What is the power? Power 3, right? Z minus 1 power 3, right? Cube, right? So z is equal to 1 is a pole of order 3, right? Now we need to find the residues using the residue form. So we know that residue at pole A of order m is given by residue of f of z power n minus 1, which is equal to 1 by m minus 1 factorial d power m minus 1 dz power m minus 1 into z minus a power m f of z power n minus 1. Instead of m you are having 3 here, right? So you put m and a equal to 1 because z is equal to 1 is a pole, right? So we will get residue r1, which is equal to 1 d cube minus 1 by dz cube minus 1 z minus 1 whole cube z power n z plus 1 by z minus 1 whole cube, right? So 1 by 2 factorial limit z tends to infinite d square by dz square z minus 1 whole cube in the numerator, and the denominator also you are having z minus 1 whole cube. So get cancelled. So remaining z power n into z plus 1. Now is equal to 1 by 2 factorial 2 factorial 2, right? 1 by 2 limit z tends to 1 d square by dz square, splitting that z power n into z power n plus 1 and 1 into z power n, so you will get z power n. Now we'll take first derivative 1 by 2 into limit z tends to infinite, sorry, z tends to 1 d by dz of, I'm splitting, right? So first d by dz of z power n plus 1 plus z power n, right? That is 1 by 2 limit z tends to 1 d by dz of, we know x power n differentiation with respect to x, n plus 1 into x power n, right? Or x power n into x power n minus 1. So you have to reduce 1 in the power. Similarly here n plus 1 into z power n plus 1 minus 1, so you will get z power n. Second term n into z power n minus 1. Now again another differentiation, second differentiation 1 by 2 limit z tends to 1, n plus 1 is constant, so derivative of z power n into z power n minus 1 first term. Second term n constant, so n minus 1 into z power n minus 1 minus 1, you will get n minus 2. Now applying the limit z is equal to 1. So 1 by 2 n plus 1 n into, put z is equal to 1 power n minus 1 plus n into n minus 1, z is equal to 1. So power n minus 2. So you will get half into n plus 1 into n plus n into n minus 1. So splitting 1 by 2 n square plus n square minus n plus n minus n get cancelled. So you will get 2n square. Numerator 2 and denominator 2 get cancelled. So you will get finally n square, right? Therefore, R1 which is equal to n square, right? So some of you here you are having only one residue, that is n square. So therefore, the relation between Z and Fourier transform, we know f of n is equal to 1 by 2 pi integral over C f of Z power n minus 1 dz. So therefore, substituting that values, so and we know by Cauchy's integral formula, Cauchy's residue theorem, integral over C f of Z power n minus 1 dz is equal to 2 pi I into sum of the residues. That is also we know. Substituting both, so you will get 1 by 2 pi into 2 pi. So residue of f of z power n minus 1 equal to n square, right? So substituting 2 pi and 2 pi get cancelled. So you will get n square. That is the inverse z transformation of given function, right? That's all. Thanks. We'll see you in the next video.